All right, guys, this is the first lesson in the pre-calc in the book. Okay, so we've done some things already, some review and new stuff on sequences, but this lesson is really a lot of review. We're going to start with really simple stuff about percent increase. Does anybody remember how you would find the percent increase in this from 45,000 to 53,000? Wow, look right down here. It says the amount of change over the original. So how do we find that?
Take 53,340 minus 150,000.
And then that's going to give us the amount of change, and when we're all done, we're going to divide by which one?
45.
The one it started with, yeah, because it's at 1% of increase. You can actually take this one divided by this one, but then you have to subtract off the 100% because it wants only the amount of increase. This is going to give us a decimal, and we're going to need to move the decimal over a couple times. So what are we coming up with?
17%.
Roughly 17%? Or exactly? I don't know.
17.3.
Okay. 17.3 would be fine as well. Alright, B says find the sales tax on an item costing this. Now, you guys are so smart that you get this wrong because you do more work than you're supposed to. What are we supposed to find? Only the tax, not the total due. Okay? So just take what? 39.95 times what?
0.07.
Good job. And fill that in. 290. Thank you. So far, so good? Easiest day yet, right?
Yeah.
All right. The next section is reviewing all the subsets of real numbers. Real numbers are everything except imaginary numbers. Okay, so we don't have any i's. Rational, here's all the definitions down here. Rational numbers can be written as a ratio, so they include fractions, whole numbers, repeating and terminating decimals. So that's pretty much everything we're going to talk about, except things like square roots that don't come out nice, things like pi that never repeat. Okay, we're also going to learn eventually, I think you've all seen E before, right? Natural log. Remember something about that? Okay, so that's also an irrational number. Whole numbers include only the wholes without the negatives. Okay, integers include positive and negative whole numbers. The natural or counting numbers, I always think of it this way. When your mom taught you to count, or the natural thing you start out with when you count is 1, right? So it doesn't include 0. So counting numbers 1, 2, 3. All right, so let's see if we can fill in this little chart with all this information. What's the one thing that the oddball out that we only have a few of? Irrationals. And can you give me a couple examples to write in here? Pi, square root of 7, square root of 231, all kinds of ugly stuff, right? E. Alright, we're not going to have room to put too many examples of these other things, but over here we have rational numbers. And that's everything that can be written as a fraction. So it would include 1/2, -4, 7/3, which would be a repeating decimal. I don't know, is that enough examples? Anybody figure out what the smallest subset is here? The smallest one would be your natural or counting numbers, because it only has 1, 2, 3, 4, 5, and so on. Okay, if we included 0, do you remember what we called it then? The whole numbers? Which is kind of weird because 0 isn't seem like it's a whole anything, right? But and then what if we included the negatives? It's the integers. So on the quiz that will occur Friday, you will have to put some check marks or X's or someplace or something behind in a number of situation like this. So negative 58 falls into which of this category, guys? Okay, let's go back 1 second. Over all of this, guys, these are all real numbers, okay? These are all real numbers. If we had another category down here, we would have imaginary or complex numbers. All right, we said negative 58 is what? It is rational and real. It is an integer. Very good. All right, 42.6. What do you think? Is it rational? Can we write it as a fraction? Be 426 over 10, right? Which could reduce. So it is rational. What else? They're all real, yep. That's it, right? Square root of 23? Irrational and real. Alright, so I think you could handle that?
Yes.
The next part, I have a couple slides here just of reviewing what a fraction is. X, the value that you put in to the function, and y is what comes out. That will also sometimes, instead of y, be written f of x. Does that sound familiar? Okay, so we have function. Function has a special set of rules. It has to work for every possible input value, and each can only have one output for every input. Okay, so remember we did little charts like this sometimes, a mapping. A function relates each element of a set with exactly one element of another set called the output or the range. So does this look familiar? You can't have one value in the x going to two different values in the y. But it's okay if two values from the x go to a single value in the y. Did I just say that backwards?
I don't know.
X can't go to two different y's, but two x's can go to the same y. Miss Abruzzo does something about two girls can like one boy, but two boys can't date the same girl, or I don't know, some crazy thing, and I always get confused anyway. So, all right. So here, is this a function or is it not? And then we're going to talk about what the domain and range are. Is this first one a function? 3 goes to 4 and 3 goes to 3. So if we did a mapping, we'd have 3 and 1 here, and 3 would go to 4 and to 3 over here. Is that okay or no? No, this is not even a function. If we were listing the domain, it really isn't a function, so it doesn't have a domain, but the values would be 1 and 3. And the range would have values of 2, 3, 4, and 5. This is a list, so you don't really have to put it in interval notation because you don't know. Is 1.5 part of it? Is 2 part of it? We don't know. It's just specifically 1 and 3. And 2, 3, 4, and 5. Some people would tell you have to put set notation and so on. I'm going to go ahead and write down domain and range, even though we said it wasn't a function. Just to review this. All right. What about here? Is this a function? I bet some of you could even figure out what the rule is. What's the rule for this function? Yeah, they're multiplying by 3. But it is a function. And the domain, written the way it is, the domain is just the set of numbers 1, 2, 3, and 4. Because we don't know if it goes on forever. And the range is the set of numbers 3, 6, 9, and 12. All right, how do we decide if this is a function? Something that's been graphed. All right, we're going to use the vertical line test. I think I have a slide on that, so I'm going to go ahead and go to the next one here. It's not very big. Those are in the back. I hope you can see, but On a graph, the idea of a singled value means that no vertical line would ever cross more than one. So if a vertical line crosses it more than one place, it is not a function. Everybody remember that rule now? Okay. So if we go back to this one, does this one seem to be a function?
Yes.
Okay, so we write yes. The domain, do you remember how you read a domain on a graph? It's x values, so x values are from left to right. So this one does seem like 4 to 13. Now, does it look like it could be 4.1, 4.2, 7.8? So I'm going to go ahead and use interval notation. Does anybody remember why I'm using the little square brackets?
That includes 4.
Yeah, because it seems like there's a including 4 and including 13 endpoints there. Is anybody not familiar with the interval notation? Because I have a worksheet on interval notation, it's just I'm not sure we need to do it. Did everybody learn interval notation in another class? Like with the infinities and everything? Okay, if you're not, please let me know, because I can just give you a little lesson on your, on the QT, and no one has to know that you didn't know. Range reads from what? Least to greatest, so that would be the bottom y value to the top. I just had a big argument with my daughter about this, because she says, since I'm drawing this line and this line and they're going across, that range is across. Is range really across? No, I'm drawing a line across the top and the bottom, but I'm reading the difference up and down, right? So just so we're clear on that, because she is not clear on that. What is the minimum value? 1, and it looks to me like we just need hard brackets again. And the upper value? 8. All right. All of that should have been reviewed, yes? We're good? Okay, this is the next part on your notes, I think, is something like this. I found this nice slide that explained it fairly well. F is the function name, or f of x, the whole thing. X is going to be our input, and this is going to be the rule that gives us the output. So this one you would say f of x equals x squared. So on this slide right here, where are we going to write the word input? X is the input, so I'm going to squeeze it in right up here. Okay, where am I going to write output? I don't know. Maybe we should keep going and figure that one out as we go. Name of the function? What's the name of the function? G or g of x. I'm kind of confused. I'm going with g as the name. And the directions for finding, I know where that goes. Which one's that? The 3x squared minus 7. These are the quote-unquote directions. I'm just going to write directions. Or the rule, I would have said. And so this whole thing, g of x, is called y, which is the output. All right, that was kind of crazy. As long as you know what all those things are, there's not going to be a vocabulary quiz on any of that. All right, what's the only one here? Well, do any of these seem tricky? Should all be review. I'm a little bit worried about the -2. Why would I worry about the -2? Yes, when you square -2, if you're using a calculator, which I don't know that anybody needs a calculator on this problem, but you would need parentheses around the -2. And the a+1, I'm thinking I'm going to be mean. We're in pre-calc. We're going to have to simplify that, okay? So let's run through these really fast. When we put a 3 in, we have 3 times 3 squared minus 7. 9 times 3 is 27 minus 3. Did everybody get 20? I heard that answer really fast. Okay, -2. 3 times -2 squared minus 7. You would need the parentheses. 4 times 3 is 12 minus 7. Is it 5?
Yep.
All right. This one, I could be nice and just let you write 3 times the quantity a plus 1 squared minus 7. Everybody okay with where I got that? Alright, what if I mean? Because I want to know that you know how to square a plus 1, and it is not a squared plus 1, right? Jacob, yes, we have to distribute the a plus 1 times the a plus 1. Does it matter if I want to do this 3 first or not? I can multiply in any order. I wouldn't. I would go ahead and FOIL this out. What do we get? Somebody? Did I confuse anybody? You know where we got 2a? 1a and 1a, we're good? Now we got to distribute a 3 and then subtract a 7. What are we getting? 3a squared plus 6a plus 3, and then the minus 7 would be minus 4. Is that okay? I'm going to run out of room if I have to write it again. Everybody know where I got that number? Sorry guys, I forget how hard it is to see in the back. Just yell at me to move it up anytime. Are we good? Awesome. I think we're almost done with today's notes because we're going to talk about graphing on a scatter plot. Scatter plot has, this one says grade versus time in the lab. It's really important that whatever is identified first is the vertical axis, and vertical means which way? Yes, so this is going to be grade, and they have it as a %. And versus time, this is going to be hours in the lab. Going this way. Does it look like we can probably count by ones going across this way? But up and down, we might have to go by what? I'm just going to label like 1, 2, 3, maybe go by tens this way. Alright, I'm not going to try to label them all. Can you guys try to fill in those dots fairly accurately? 4, 41. Oh my gosh, I can't see it all. Let's put a big old dot somewhere there. 14. All right, 747. $10.64. $5.91. $16.83, $8.86. And $15.69. Did anybody else get a scatter plot that looks vaguely like mine? Oh, it did even tell us to count in tens on the Y. Find the domain and range of the scatter plot. Because it is a scatter plot, we really don't want to write an interval notation. So we would just list these. The domain is what numbers? Can we put them in order? 4, 5, 7, 8. What am I missing? 10, 14, 15, and 16. Did I get them all or not? Okay, and the range would be the Y values. can we talk about correlation for a second? Does there seem to be a nice pattern to this where we can tell that as you spend more hours in the lab, your grade increases? No. This is definitely not a strong correlation. Okay? We have people who only spent 6 or 7 hours 5 hours in the lab and got a 91%. And then we have somebody else who spent 3 times that much and got a worse grade. Okay, so there is no clear correlation between these two quantities. We will talk more about correlation later in the chapter. I can't remember. Does this start on 1.2 notes now or not?
Yes.
Okay. I'm thinking that we're going to be done for today on notes. What time are we out of here?
18. No, 46. That's right there.
26? Okay.